Good morning, students. So, I am Professor Gopal Surupalli, Department of Civil Engineering. Welcome you all for this session. Okay, in the previous session, we have solved problems on calculation of moment. So, let us take two more problems, right? So, we're going to solve the problems that is on how to calculate the moment of a force about a particular point. So the problem is like this: determine the moment of a force 100 Newton acting on the rod as shown in figure about O. Okay, so this is the rod, 4-meter rod. This is inclined rod making an angle of 30° with the horizontal. So this is point O and this is point A. So at A there is a force now like this 100 Newton force, and this 100 Newton force is making an angle of 50° with the horizontal. Okay, so this is the inclined force of 100 Newton acting at an angle of 50° to the horizontal at point A. Now we have to find out moment of this 100 Newton force about point O. Okay, so in this problem, now see, so this is the force. If I extend this force, I'll not going to get the perpendicular distance like this. So what happens? We're going to resolve this force along horizontal and vertical. Now let us draw one more diagram. Same rod, okay, which is making an angle of 20°. Okay, then this is point A. Okay, at point A now there is a force 100 Newton force. Okay, this 100 Newton force is making an angle of 50° with the horizontal. Now see, this is 50°. This is a horizontal now. Okay, the force 100 Newton force making an angle of 50°. Now this is 50. Okay, so now if I take, this is the axis of the rod. Okay, so this is the axis of the rod. If I extend this axis, see, I will going to extend this axis now. So this is the x-axis now, not this x-axis. Okay, if I take this axis of the rod itself as x-axis like this, this is x-axis now, see, and perpendicular to this is y-axis. Is it right? Okay, so now we have drawn x and y axis. Now let us resolve this 100 Newton force along x axis and along y axis. Okay, now see, this force is making an angle of 100 making an angle of 50° with this horizontal axis. Not, this is not x axis now, this is x axis. Okay, so this force given 100 Newton is making an angle of 50° with the horizontal. This is horizontal now. So if this is 50, okay, then see, at point O, this rod is making an angle of how much? 20° with the horizontal. Now, this is the axis now, same axis I extended. This x-axis I extended. Okay, then this is a horizontal line parallel to this. If I draw a line here, okay, this is a horizontal line. So is it 20 now? Right? This angle is 20°. See, because this is 20 means, okay, automatically this will be 20 alternate angles. Okay, if this is 20 and this whole, that is force to the horizontal, is 50°. So 50 minus 20, this minus 20, so remaining is 30°. So what is this 30°? 30° is nothing but the angle made by this 100 Newton force with x-axis. Okay, 30° is angle made by the 100 Newton force with x-axis. Now once if you get this 30°, that is the angle made by the 100 Newton force with x-axis, so now resolve this force now. 100 Newton force can be resolved along this x-axis and along y-axis. Okay, so if this is 100 and this angle is 30°, then what is the component now? 100 cos 30. So see, this force, the component of this 100 Newton along x-axis is 100 cos 30. This force is 100 cos 30, and resolve this force vertical now. Make this force vertical like this. So this is 100 sin 30. Okay, 100 cos 30, 100 sin 30. Now instead of this inclined force 100 Newton, I can take two forces acting at point A. One is 100 cos 30 and one more is 100 sin 30. Okay, now you can take moment of this force about O, then moment of this force about O. Now see, now what is the moment now? So moment of 100 Newton force about O is given by, so MO, moment about O is equal to first force. I'll take this force now. So with reference to this O, what is the moment of this force? So this will going to be anti-clockwise. Okay, anti-clockwise means minus. So minus 100 sin 30 into perpendicular distance between this force. Now force is like this, and where is point O? This. So what is the perpendicular distance now? This is 4 meter. Is it right? So this is 100 sin 30 into perpendicular distance is 4 meter. So minus 100 sin 30 into 4. Then this force, what is the moment of this 100 Newton, 100 cos 30? 100. Now see, this force is exactly passing through O only. Okay, so there is no perpendicular distance. So no perpendicular distance means no moment. So this moment of this force is 0 only. So only it is minus 100 sin 30, minus is anti-clockwise, minus 100 sin 30 into 4. So minus 100 sin 30 into 4 plus that moment of that force is 100 cos 30 is 0. So this comes out minus 200 Newton meters, because force is in Newton, distance is in meter. So minus 200 Newton meter. What this minus indicates? It is anti-clockwise. Remove minus sign, write 200 Newton meter. Minus is because of it is anti-clockwise. Okay. So this is the moment of this 100 Newton, or you are resolve this force, this force into 2, 100 cos 30, 100 sin 30. Then you have taken moment about O, this 100 sin 30 into 4 minus, then this will be 0, because this is exactly passing over point O, there is no moment. Okay, so this is the problem. The next one more interesting problem we're going to consider. So the problem is like this: the moment of a certain force F is 180 kilonewton meter clockwise about O. Okay, so try to read the problem once again. There is a force, okay, there is a force F, okay, and the moment of this force F about O, moment of this force F about O is how much? 180 kilonewton meter. Okay, moment of F about O, that is MO, is given 180 kilonewton meter clockwise about O, and 90 kilonewton meter counterclockwise. Counterclockwise means anti-clockwise. So 90 kilonewton meter anti-clockwise about B. So there is a force F. The moment of this force F about O is 180 kilonewton meter, and moment of this force F about B is 90 kilonewton meter. So two moments are given. So moment of F about O and moment of F about B is 90 kilonewton meter clockwise. If its moment about A is 0, okay, there is one more point. The moment of this force F, A is 0, determine the force F. So see, three moments are given, and we have to identify where is the force F. So this the simple diagram given. So this is point A. Actually, this is point O. Okay, this is point O, and this is B. Okay, so now as per the problem, so there is a force, we don't know where it is. There is a force F, and the moment of this force F is 180 kilonewton meter clockwise about O. The moment of that particular force F about O, this is O. Okay, the point O, the moment of force F about O is 180 kilonewton meter clockwise, and the moment of F about B is 90 kilonewton meter, and it is anti-clockwise. So about B, if if its moment about A is 0, right? So this is important. Moment of that particular force about A is 0, right? Then determine the force F. So try to understand this problem. Okay, those, there are two moments. One is 180 kilonewton meter about O and 90 kilonewton meter about B, because of there is a force, certain force F. And the third moment, that is moment of that particular force about A is 0, then automatically it indicates that the force should be at A only. Okay, the force should be at A only, such that if you provide force F at A, these two conditions should be satisfied now. Okay, if I provide, see, if I provide horizontal force here F, okay, so no doubt it should be at A only. Okay, it should be at, because the moment about that particular force is 0, means the force should be acting at A only. But the question is whether this force is horizontal or whether it is vertical, that you have to identify. So if you provide horizontal, all the three conditions should be satisfied. That moment of this force about A is 0, that will going to satisfy. Then moment of that particular force, now if I provide force like this, what is the moment of this force about O now? So this is clockwise. About O, it is clockwise and it is given 180 kilonewton, right? Then moment of this again horizontal force about B is 90 kilonewton meter anti-clockwise. Now if I provide horizontal force like this, so no doubt it will going to satisfy. Moment about A is 0, then what about moment of B? It produces clockwise, but moment of about B is how much? It is anti-clockwise. So it is not in this direction. The force is not in this direction. Even if you provide vertical also, it will not going to satisfy these two conditions. So no doubt the force must be at A, but it should be inclined like this. It should be inclined. Even if you provide horizontal, it will not going to satisfy. Even if you provide vertical also, even if you provide downward force also, it will not going to satisfy. Or even if you provide force like this, it will not going to satisfy. The only solution is, no doubt it is at A, but it should be inclined. So now provide the force at A, it is F, which is making an angle of theta with the horizontal. Okay, we have to calculate what is the force F to satisfy the condition 180 kilonewton meter and 90 kilonewton meter about O and B. So force, apply the force F at point A, which is inclined, making an angle of theta with the x-axis. Now this is x-axis, this is y-axis. Okay, this is important. Now since it is an inclined force, I can resolve this along horizontal and along vertical. Now if you make a horizontal, make this force horizontal. So what is component? F cos theta. This is F, this angle theta, and this horizontal force is now F cos theta. Make this vertical now. See the direction, it is downward now. When you make this vertical, it is downward. So vertical force is F sin theta. So F, if you have taken horizontal cos theta, then vertical will be F sin theta. So instead of this inclined force, now we have the two forces at point A. So one is F cos theta horizontal, then F sin theta vertical, but it is downward. So now this is A, this is O, and this is B. Now conditions we have to use. So this length is 3 meter and this is 6 meter. So there are two moments given. One is moment of that particular force about O, right? Moment of that particular force about O is, right? So clockwise 180. Now see here, moment of certain force F is 180 kilonewton meter clockwise about O. Okay, about O. So first we will take that moment of force about O. So MO is given now. So MO is equal to, now there are two forces. So take moment of these two forces about O. So this will going to pass through O only. Okay, this F sin theta will going to pass through O only. So the moment of this will be 0. Then what is the moment of this force about O now? So with reference to O, this is clockwise. So clockwise means plus. So plus F cos theta, and the perpendicular distance between this force and O. Now this is the force, this is point O. What is the perpendicular distance between these two? Is 3 meter. So clockwise means plus F cos theta into 3, and moment of this will be 0 only. So therefore MO is equal to F cos theta into 3. So MO is given, see here. Okay, 180 kilonewton meter clockwise about O. Clockwise means plus 180 is equal to F cos theta into 3. So from this I can find out F cos theta is equal to 180 by 3. That is F cos theta is equal to 60 kilonewton. F cos theta is equal to 60. Right, this is equation number 1. We have to find out F now. So, but equation what you have got? F cos theta is equal to 60 kilonewton. Write this as equation number 1. So this is condition we have to what we have used. Moment of that force about O is 180 kilonewton meter clockwise. Now second is moment of that same force F about B. About B is anti-clockwise and it is 90. So now we are going to take moment of these two forces about B only now. B you have to take, and this moment MB is equal to anti-clockwise. Counterclockwise means anti-clockwise, that is 90 minus 90 now. Anti-clockwise means minus you have to take. So now taking moment about B. So MB is equal to again two forces. Moment of these two forces about B now. So one by one. So what is the moment of this now? So with reference to B, this will going to produce clockwise means plus. So plus F cos theta, and what is the perpendicular distance between this F cos theta and B now? This is a perpendicular distance. So perpendicular distance is 3 meter. So moment of this force about B is plus F cos theta into 3. Then what is the moment of this force now? Now with reference to B, this will going to produce anti-clockwise. So minus. So moment of this force about B is minus F sin theta into what is the perpendicular distance between this force and B is 6 meter. So moment of these two forces. First MB is equal to plus F cos theta, clockwise means F cos theta into this distance is 3 meter. Then moment of this force is anti-clockwise minus F sin theta into perpendicular distance between this force and B is 6 meter. That's what we have written here. So MB is equal to plus F cos theta into 3 minus F sin theta into 6. So this is given. Moment about B is counterclockwise means anti-clockwise means you have to take minus 90. It is given. Counterclockwise 90 kilonewton meter is given. Anti-clockwise means minus 90 is equal to F cos theta. Equation, what is F cos theta is equal to 60. So substitute here. So F cos theta is 60 into 3 minus F sin theta into 6. So I will take this term here. So this becomes plus F sin theta into 6, that is equal to 60 into 3 180. This comes this side, it is plus 90. So F sin theta into 6 is equal to 270. Then F sin theta is equal to 270 divided by 6. It is 45 kilonewton. Now we have got another equation. F sin theta is equal to 45. Now here equation number 1 is F cos theta is equal to 60. Then equation 2, F sin theta is equal to 45. So now there are two equations. Now we have to find out F. So what I am going to do? Divide this equation 2 by equation 1. So dividing this equation 2 divide by equation number 1. So here F sin theta, okay, F sin theta divided by F cos theta. Divide equation 2 by this equation 1. So F sin theta divided by F cos theta, that is equal to 45 divided by 60. Okay, 45 divided by 60. Now here F get cancel, same F get cancel, then sin theta by cos theta is tan theta. Okay, so tan theta is equal to 45 upon 60, right? So theta is equal to tan inverse of this. Okay, theta is equal to tan inverse of this. So angle will get 36.87 degree. Means the force at A is making an angle of how much? 36.87. Now what is the value of F now? Now substitute this theta value. Substitute theta value either in equation number 2 or in equation number 1. Any one. In any equation you can substitute, we'll get the F. So substituting the theta value in equation 1. So what is equation 1? Now see, equation 1 is F cos theta is equal to 60. Okay, F cos theta is equal to 60. So F into cos theta is equal to 60. So F cos theta is 36.87. So F into cos of 36.87, that is equal to 60 kilonewton. So therefore F you can calculate 60 divided by this cos 36.87, will get F as 75 kilonewton. So the force is 75 kilonewton and it is acting at point A, then it is making an angle of 36.87. Now see, the force should be at A, which is inclined, making an angle of 36.87, and its value is 75 kilonewton. Then only you are going to get moment of this force F about O is 180 kilonewton meter anti-clockwise, that is clockwise, and moment of this force about B is 90 kilonewton meter anti-clockwise. So this was the problem. So please note that this problem is important. Okay, so note down this problem, whatever you have solved, these two problems are important. So hope you have understood these problems. If any doubts are there, so you feel free to ask, okay, and clarify your doubts. Okay, so we'll come up with some more interesting things in the next class. So thank you very much for attending this session. So thank you.